All right.
I'll just intro you for the recording. We'll throw away the old one. Thank you very much for our next speaker, who is Erin Heerey, who is a professor at Western in the Department of Psychology. Thank you very much, Erin.
So I'm going to be talking to you today a little bit about the other side of the coin here. We've heard a lot about data analysis. We've heard a lot about kind of the computer-based side of data collection and dealing with data. And I'm here because I study face-to-face human behavior. And so I study the really on-the-ground personal data collection side of things. So what my lab does is we're interested in how the subtle social cues that people exchange actually affect what happens in, how people behave and how people use those cues to make decisions. So human behavior, funny enough, is really big business. And if you do a really quick Google search, you'll find you can spend tens to hundreds to thousands of dollars. You'll find books, you'll find training sessions, you'll find leadership events, that all of which will promise you that you can build your self-esteem, that you will be more likely to be selected as a leader in your organization, that you can, be a better person. And unfortunately for us, psychology has a dirty little not so secret, which is that we are in the middle of a replication crisis. And you don't need to take my word for it. There are hundreds and hundreds of articles out there now suggesting that over the last kind of, 10 to 15 years, we've really been struggling with leadership, with reproducing effects in psychology. And there were a bunch of reasons for it. Some of those reasons have to do with practices associated with data analysis, and some of them have to do with practices that happen right in the sort of experimental sessions. And you've heard about small samples, you've heard about sort of how should we say it, motivated data cleaning methods. We've talked about statistical reporting issues, but the thing I want to talk about today is conflicts of interest. And I'm not talking about the financial ones where I stand to make a buck off the back of my results. I want to talk about a different one. So I'm interested in, and the thing that makes me interested in this topic is the human behavior side of things. And I'm interested in motivated experimenters and how they behave and what they do. So when you walk into an experimental session with your theory, you're thinking about your theory, and you're thinking about, jobs, you're thinking about your next paper, you're thinking about your next grant, and all of that might combine to actually shape what happens in the experimental session. So that's basically what I'd like to chat with you about today. And I want to tell you what happened in my lab. And in particular, I'm going to talk about experimenter effects. So experimenter effects are these demand characteristics that get introduced. It's it's basically a form of bias that gets introduced based on the fact that experimenters who are not blind to study hypotheses, to participant condition, and so forth, actually can introduce bias into the data collection process, even independent of the analyses that people do. So experimenter effects are very interesting to me because of the social behavior aspect of things. And I'm going to tell you the story of how we discovered them in our lab. Now everybody hears about these in their very first kind of undergraduate research methods class. Oh, you need to be careful, double blinding is a good idea. And then what many people in social sciences, which is where I'm from, get told is that, actually, but it's really hard to do this well. And so just try to be a conscientious experimenter, and then experimenter effects won't happen to you. Good. Okay, so far so good. So these turned up in my lab because I had a graduate student who wanted to study a social psychology phenomenon known as power priming. So in power priming, the idea is that I give you a subtle cue associated with a position of status. For example, I might ask you to come into my lab as a participant, and I might ask you to write with a pencil and paper about a time when you felt like you had a lot of power, when you had high status, and so forth. And when people have these subtle cues associated with high power, they change their behavior on subsequent dependent variables. So people become more egocentric, they become more approach-oriented, they think in more abstract ways, they have cognitive advantages on a number of different kinds of tasks. Conversely, when people have low power cues, they write about a time when they were not in power, or they unscramble some sentences that have low power relative to high power words in them, like employee instead of boss. People become more emotional, they become more sort of other focused, they become more passive. So a number of years ago, I had a graduate student who was really interested in this stuff. She was from South Africa, and she was sort of steeped in this kind of power dynamics amongst people, and had lots of anecdotal evidence about how this might play out. So she developed a really nice paradigm. She came to me and said, I want to do this. And I said, I have one condition for you, which is that you need to be blind to which condition your participants are in. And so she said, okay, we got the task working. And on day one of data collection, she was genuinely blind to which participants were in which condition. And then she figured out the double blinding. I did the double blinding, and I'm afraid I might have been a little bit sloppy. It wasn't a true randomization to condition. It was based on counterbalancing. And she figured it out. So we have data that she collected blind and data that she collected not blind. And so we compared them. And it turns out that we found the effect she was expecting and hypothesizing when she knew who was in what condition. And she found absolutely no difference between the groups in the other condition. So then we wondered what was going on. And we decided to study this experimentally. We decided to ask the question of, what happens when we manipulate, when we do this in a 2x2 design, where the experimenter either has accurate knowledge of what prime a participant received or when they don't. So just to kind of, give you a little bit of an overview about the priming idea here, participants in one condition might get a prime that attenuates behavior on a task, versus some other participants get a different prime where their behavior is supposed to be enhanced. Now, funny enough, almost every single study in the literature when we began this project had experimenter belief about condition matched exactly the condition that was being tested. So we thought, well, what happens if we manipulate the experimenter's belief? And sometimes when the experimenter thinks prime A is active, it's actually prime B, and vice versa. And we wanted to know what would happen to the results. So there are two interesting outcomes that can happen here. One of them is an outcome that looks like this, where even though the experimenter thought prime A was active, when participants received prime B, they responded, they had an enhanced effect, and vice versa. And that tells you that your prime has had an effect. You can also have the other thing happen, where the participant's behavior exactly follows what the experimenter is expecting, in which case you have an experimenter effect. So that was the question we were asking here. So we set up a study design that allowed us to measure this in a really direct way. And what we did is we started with a series of experimenters who set up the study session for a participant by entering the code on the computer. And they worked from a list, and we were not subtle here. They entered H for high power and L for low power. And they assigned 50% of the participants to the high power condition, 50% of their participants to the low power condition. And then what we didn't tell our experimenters, or at least the first thing we didn't tell them, was that actually what really happened was the computer randomly assigned participants to either the same condition the experimenter assigned them to, or to the other condition. So each experimenter ran all four of these conditions, where the participant got the low power prime and they thought they got the low power prime, they got the low power prime, but the experimenter thought it was high power, and so on. So what then happens is the experimenter brings the participants into the room and gives them some task instructions. Now, this is the important phase where experimenter effects seem to happen. This phase lasts 2 to 3 minutes. Our experimenters were well trained, they worked from scripts, and they told the participants about the task they were going to complete and asked if they had any questions. And then they left the room and closed the door. So for the whole rest of the session, the only interaction that participants are having is with the computer. So there's no more interaction between the participant and the experimenter. And if a participant had questions during the task, we actually trashed the participant. We just deleted their data. Now, what might experimenters be doing during this phase when they're providing instructions? We weren't sure, but we suspected that something was going on there. And so because we couldn't video record this or do anything without alerting our experimenters to the fact that they were actually the experimental subjects, we actually had our real participants complete some ratings at the very end of the study. So at the very end of the study, a little screen came up that said, there are multiple experimenters collecting data on this project. We'd just like you to rate your experimenter so we can make sure that they're, doing what they're supposed to be doing. So they rated them on 4 traits. They rated them on competence. And then we also asked how friendly, how trustworthy, and how attractive did you find your experimenter? So we did this a bunch of times. We had a bunch of pilot testing, and then we actually ran this process. And I'm going to show you data from 4 experiments here. And I'm actually going to show these to you as a meta-analysis because we did a little mini meta-analysis on our own results to get the overall effect of how much variance is due to the prime condition and how much variance is due to the experimenter's belief. We also did this with a number of different experimenters and a number of different kinds of dependent variables. So we use exactly the same manipulation of power priming on a bunch of different dependent variables. All of these have been used in the literature. There are hundreds of studies on power priming in the literature. So in the first study, we looked at people's ability to think in abstract ways. And it was kind of a small sample, only 113 participants. We had 2 experimenters running this. And what we found was, unfortunately, no effect of prime condition, but an effect in the predicted direction of experimental belief. Okay. In experiment 2, we studied risk-taking. And actually, the results are rather similar. In experiment 3, we used a categorization task and found essentially the same results. And in experiment 4, we actually had a large number of participants, 400 of them, with 4 experimenters, and found the same results. And overall, what we found is that the priming doesn't really matter here. And what matters is the experimenter belief. Now, from my perspective, this is a really cool finding because it tells us about those really subtle cues that change how people behave and that actually can shape the data that gets collected in your study. So what were these folks doing? What were these experimenters, by the way, who were not aware at the timing of when they collected the data, what was actually going on? We were really careful to keep them blind to this. Well, double blinding probably should be standard. And the reason happens is that we actually looked at the rating data from how participants rated the experimenters depending on which condition the experimenter thought was active. Remember that experimenters tested participants in all of the conditions. So it turns out that when the experimenters thought participants were in the low power condition, the experimenters were rated as less friendly and less trustworthy and slightly less attractive to when they were in the high power condition. There were no differences in competence. So that tells us that experimenters were perceived differently based on their own beliefs about task conditions, which tells us that they were behaving differently, even though we don't know exactly what they were doing. And that a 2 to 3 minute interaction from a script at the beginning of this is sufficient to cause this effect, which is, well, it was rather shocking to us. And then we went back and we really looked carefully at the literature. And we did a review of 253 of these articles. And we found that double blinding procedures were clearly described in 8 of them, which is about 3%. And they were mentioned off the cuff, as in, oh yeah, you know, experimenters were not aware, but they didn't tell you how they did that, in 21 of them, which doesn't lend a lot of confidence to this sort of hypothetical social psychology. Priming is a pillar in social psychology. It doesn't lend a lot of confidence to what this pillar looks like. And we were rather shocked at how, at the extent to which we saw consistently across different experimenters and different participants this effect. I will tell you that not all of our experimenters showed experimenter effects. Of the 11 experimenters we used, only 9 of them showed effects. 2 of them did not, one of whom was doing this as an honors thesis, and that person did not believe that experimenter effects would happen, or that priming effects would happen, and they didn't find any. And they were not rated differently. And so that's an interesting piece. The other one just didn't show the effect. So not all experimenters show this, but it's something that we should keep as standard in this field. So one of the things that, that we need to think about from the other side of the equation, the data collection side, is we really need to try to improve strong double-blind procedures. This is a gold standard in clinical trials, for example. If you are looking at randomized clinical trials of vaccines or medicines, double-blinding is standard, but it is not standard in normal experimentation practices. Another process that you could use to minimize that contact, or at least make the contact standardized across participants, is video recording your instructions, which allows you to, even if the experimenter is very motivating or very captivating or however they are, everybody gets exactly the same thing. We need better random assignment to task conditions. And sometimes that doesn't work. For example, if you're working with clinical populations, it's almost always the case that an experimenter might know what condition the participant is in. And in those cases, it's really important that experimenters are blind to study hypotheses. There are also studies where the experimenter sits next to the participant the whole time and gives them motivation. And in those kinds of studies, this happens a lot with motor control studies and with studies where people are in fMRI and other things. And so in those cases, I think it's really important to analyze these experimenter effects and to do your best to control them by using better double blinding practices. If you'd like to read about it, there's the citation, but I will stop there and ask if people have questions.
Thank you, Erin. I'm just absolutely blown away. It's just remarkable. Does anyone have any questions? Feel free to raise your hand. I can call on you. To what extent, I mean, you went through 250 or so, and you looked at papers, and you looked at whether or not they mentioned double blinding, and if they did, how many, to what extent they explained it. And it's basically 3%.
Yeah,
you mentioned it.
Well, it's 3% described it clearly.
Beg your pardon, 3% described it clearly. Is it something that you think is just taking as given, and we need to do better with our instructions to authors, being like, hey, this actually really matters?
It really, I think we need to do better with our instructions to authors. And I also think that, when you're reviewing these papers, it's really important as a reviewer to look for that and to ask for it. I think it's really important as an editor, if you're editing a journal where experimental research is coming in, to look for it and ask for it. It took us about 10 years to get this study to get these results published, with a lot of work. Obviously, editors in the field who study this effect were rather, we made them feel a little bit uncomfortable. And so it's something that I think is often taken for granted. And one of the comments that we got a lot from both editors and reviewers was, oh, but most people do this. And we said, well, actually, we think most people don't, because it's really hard to do. It's hard to do well. And if you do it, you're going to describe it. So that was one of the things that we finally had an editor who thought, actually, that's probably true, and agreed with us. Abel, do you have a question?
Yeah, I do. This was great. I'm not a psychologist, I'm an economist, but I'm curious, who are the experimenters usually? Like in your experience, is it mostly students, undergrads, or like really the researchers themselves, or?
Well, often it's, so my field doesn't get a lot of funding. So usually it's the grad students collect a lot of data. Undergraduate thesis students, master students collect a lot of data. And sometimes faculty can collect. I collect plenty of data in my lab as well. So who are these experimenters? Well, they range. All of the experimenters in this study were either undergraduate honors thesis students or master students who were collecting data for their theses or their master's theses or undergraduate honors theses. And everybody likes to get P less than 0.05, which is our standard in psychology, be that for better or for worse. So because of that, we think that knowing these effects and actually many of our experimenters, because we debrief these experimenters very carefully at the end of the study, and got informed consent from our experimenters after the studies were done. And many of our experimenters reported feeling uncomfortable assigning people to the bad condition, the condition where they were supposed to perform worse. And as a result, that's totally anecdotal, but that was our, people didn't want to assign people to that condition. And so when they had to put people in that condition, they, I think, that might have actually, the student participants, because the participants were undergrads, usually from psychology research participation pools. In that case, I think they were probably picking up on the emotions the experimenters had.
Yeah, this is great. I mean, I guess what I was thinking is just lack of experience or understanding of what is the observer effect, which you could fix through teaching or just providing more information. But what you seem to be saying is it's also emotional and might be unconscious. You're doing it without even. So even if you're aware of what that is, and so that this could, like even researchers were well aware of this.
Yeah.
So anyway, that's fascinating. Thanks.
Yeah, I mean, this is, my lab has now adopted a lot of techniques to kind of mitigate these effects, given that we've now found them, including, really true double-blinding procedures that are computer-based. Oftentimes we will video record our task instructions. We will, we do our best to kind of minimize contact between participants and experimenters, but that's not always possible. I occasionally do work on clinical populations. And if you have a kid with autism, the experimenter is sitting right there. Motivating, guiding, saying you're doing a great job, keep going. So when we're in that kind of a situation, the experiment effect probably matters even more. And there have been a couple of papers since this paper came out talking about experimenters and how much contact they have with patients and just general participants in, for example, EEG studies, where you're spending a long time with the participant and capping them and applying electrodes and doing things like that, and where the experimenter seems to matter quite a lot. I've seen experiments where, with two experimenters, you've completely nullified the effects. I had a PhD student from another faculty member who came to me and said, I have this effect and it should replicate and it's not. And I said, well, let's look at your data. Which did you collect? And it turned out that the two experimenters in that data set had produced completely opposite effects, that when they were summed across, produced a totally null effect. So these things happen from time to time. Devin Becker suggests that it's, yes, social interaction might indeed be a much stronger priming effect than the techniques used in the study. So this is something that we need to really consider when we're thinking about data collection and enhancing reproducibility from kind of the data collection side rather than from the, I mean, it's certainly no more, it's equally important to do this from the statistical side, but from the data collection side, we need to think about these things as well.
I think of A/B testing, which for background, like people sometimes have different versions of websites. You could see if, putting your logo in red compared with blue results in bigger clicks, right? And one thing that they often do is AA testing, which sounded crazy to me when I first learned about it, but it's actually seeing, well, was the randomization done correctly? And in your case, like you can't afford to do this, of course, but like you almost want to AA test the experimenters, right? To see, well, is there an effect? And
yep, it's tricky to do that because in order to,
oh yeah, of course, impossible.
You have to get an experimenter to collect a lot of data.
Yeah.
So we've even gone the route of, let's try to, put our studies online as much as we can, which removes that effect entirely because their participants are interacting only with the computer, although then you don't really know what they're doing and they might be, here on the, I don't know, I think this is the Ontario campus that does the most partying. I think we're in the record for that. I mean, the students who are in these studies could be at home smoking pot on their couches while they, right? So there are all kinds of other effects you introduce in that, out in the wilds. But yeah, I think we really need to be careful and think about this in a lot more intensive a way than we have in the past.
Well, thank you very much, Erin. I actually thought that having gone through the reproducibility crisis, I now thought psychology was on a much firmer foundation, right? So I'm not sure whether to thank you for destroying that foundation or, but no, thank you very much for your presentation. I really appreciate it.